So, permutations. We're going to start first off talking about the fundamental counting principle. And like I said, this unit is a wonky one. And the reason, it's actually chapter 11 in the textbook. I do it first because people do really well on the diploma with it, but at first it's kind of overwhelming because it's something you've never heard of before. And it's kind of weird. Like, let's be honest. The word popple, or how many robots can I make if the head can be this many colors, and the middle can be this many colors, and the bottom can be this many colors. So, here we have, consider a task made up of several stages. If the number of choices for the first stage is A, and the number of choices for the second stage is B, and the number of choices for the third stage is C, then the number of ways in which the task can be completed is A times B times C times however many there are. That's the fundamental counting principle. Now, the only way we can actually use this, though, is if we're choosing one of each of those things, though. We can only choose one. One item from every stage. So if I was making a menu, let's say, and I had appetizers, main course, and dessert, and I picked one appetizer from the appetizer column, one main course, and one dessert, I can use this. But if I pick two appetizers, one main course, one dessert, I can't use the fundamental counting principle anymore. I can only pick one thing from each stage. Okay? One thing. So here we're going to look at a toy manufacturer makes a wooden toy in 3 parts. So these are, instead of stages, there's just parts. There's part 1, part 2, part 3. Now I have to ask myself, I have to only be able to take one from part 1, one from part 2, and one from part 3 in order to use the fundamental counting principle. So part 1 is the top part, and it may be colored red, white, blue, or pink. Do you see how it doesn't say and pink? It's or pink. So it's one. It's either one. So that's good. Covers one choice from part 1. Then I look at part 2, the middle part. It may be orange, black, orange, purple, or black. So one of them. It's like a Halloween middle. And then part 3 can be yellow or green. I can pick one part from there. So I know I can use the fundamental counting principle. So that's over here. So this is part 1. Now, I'm going to be completely truthful with you. It's going to be a really weird stop of pause, but I don't care. So I have part 1, and then I have part 2, and part 3. Now I want to explain what the fundamental counting principle, what all these parts mean. So I always list what's underneath it. So this would be options for part 1, correct? This would be options for part 2, this would be options for part 3, and the blank just says I'm choosing one, right? In that blank represents one choice. That's what it means. I didn't understand that. It means one choice, okay? Above that line is not how many choices you're choosing. You are choosing one choice. That's what the line means. Above it, you're putting the amount of choices there are. The line represents one choice. The number above is how many choices I have, okay? Am I picking all those colors? No. Those are the options I have. I'm picking one. That line means that I'm picking one. I did not ever understand that in high school, okay? So part 1, I'm choosing 1. And how many options do I have? 4. So above, I actually put the 4. Go. Okay, stay. And then part 2, we have orange, purple, or black. How many options do we have? 3, but we're still, the blank says we're choosing 1. Then we have yellow or green, which is 2, but we're still, the blank says we're choosing 1. And you have to understand math. If you don't understand math and you're memorizing steps, you're in trouble in grade 12 because they do diploma-style questions. There's none of this, like, convert the quadratic. Like, there's none of this, I want standard form, and you just have to do conversion. You have to complete the square and proof you have an answer. There's no such thing. That would be a procedural question. We have procedural, conceptual, and problem solving. 30% of your diploma is procedural. The rest is not procedural. So if you do not understand why you are doing something and you are a step memorizer, you're going to be in trouble. Because if you understand, it doesn't matter what question I give you, you can do them all. That's the key thing. So I will always try and make you understand why and not memorize. So, now, do we need part 1 and part 2 and part 3? Or do we need part 1 or part 2 or part 3 to make the whole robot? And. If we need and, because we need part 1 and we need part 2 and we need part 3, then we put the 3 together and we have a robot. Correct? This is the key thing. If you ever use the word and, you will multiply. And if you use the word or, you will add. Now the easiest way I've come to, this is like a little memorizing tactic, so I guess I do some memorizing. And add look like they should go together, correct? And add 3 letters, starts with an A, ends with a D, look like they should go together, but they hate each other. They do not go together. And add, no, too much similar, they do not like each other. You know, like when you have 2 similar people, they don't like each other. That's what and add. So, and does not go with and. So if and can't go with add, then it must go with multiply. Okay? So and add cannot go together. So and, you multiply, or you add. So I'm going to multiply these. 4 times 3 times 2, which is 24. And here it says, determine how many different colored toys can be produced. If it's a written response, you're giving a sentence. So 24 different colored toys can be produced. Now, I will always use the fundamental counting principle. I'm not going to use the tree diagram. But I'm going to show you the tree diagram, because if I don't show you the tree diagram, you guys are blindly following me and saying, she's right, because she's the teacher. But I'm not actually showing you why I'm right. Okay? So I want to show you using a tree diagram why the heck you actually get 24. Okay? Now, tree diagrams you would think would have branches and would look like a tree. This is more like a shrub. It shrubs out. It's like a tree horizontally. It's a tree, and it's an anti-gravity tree. Okay? So what we do is we actually list the part 1 outcome. I write part 1 up here, and then I list its outcomes below it. You have to make sure that you leave enough space between the outcomes, though, because you're going to have branches off of it, and if you put them right together, you're never going to be able to branch out. Okay? So just do what I do. Leave the space. So part 1, we have the options red, white, blue, or pink. So I'm going to give a little space red, a little space white, a little space blue, little space pink. I also never drew my tree diagrams right in grade 12. I drew them like an actual tree, not an anti-gravity tree. I was wrong every time. This unit was not good for me. Not gonna lie. So red, white, blue, pink, right? Part 1. Then part 2, you would list above, and off of it you're going to get branches because part 2 has orange, purple, or black, right? The Halloween colors. So if the top was red, the middle could be purple. I love that it's doing these little blocks. This is awesome. I do not like this. Make sure these are a little apart because you're going to get 2 branches off of these branches for part 3. Bless you. Right. So if I only had 2 parts, how many toys would there be? How many different robots? There'd be 12, right? Knowing that we could just go 4 times 3, which would be 12. Fundamental counting principle made sense, right? If I had those blanks, this would be a 4, and I need these, which is a 3, right? And the reason why is each one of these is going to get 3 of them, right? 3 branches, correct? Which gets me 12 branches. Well, we actually have 3 parts, so we have yellow or green for our part 3. And I'm going to be lazy and just go Y and G. So now I actually have 2 more outcomes and multiply by 2 and I get to 24. But I could actually list every single different robot I could have, correct? I could have red, purple, yellow, red, purple, green, red, orange, yellow, red, orange, green, red, black, yellow, red, black, green, white, purple, yellow, white, purple, green, etc., 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 which would get me 24 distinctly different toys, right? Okay. So does it make sense that it actually results in 24, not just because I told you with blanks and multiplication symbols you can get that? Now this is important more so in 30-2 than it even is in 30-1 because we do probabilities of these things. So if I asked you what's the probability of getting a pink, orange, yellow, or pink, orange, green toy, you'd have to know how many of those there exist. So you'd have to do the tree diagram so you could actually visualize the outcomes. So it actually is harder, this topic in 30-2 in some ways. Okay, so here I have a school cafeteria offers sandwiches made with fillings. So we have fillings of ham, salami, cheese, egg, on white, whole wheat, whoopsies, I don't even know how that's, whole wheat, oh my gosh, really? Or rye bread. Now, how do we know if this is a fundamental counting principle? Well, we have parts. We have fillings and we have bread, correct? But what's the only way I can use the fundamental counting principle?
One from each category.
One from each category. I can take one filling and one bread. So if I'm allowed to have two fillings, no longer can I do fundamental counting principle. I'm actually have to use combinations, which is way down the list of lessons for doing. So here we have to keep reading. It says how many different sandwiches can be made using only one filling and one type of bread. Oh my gosh, really? This is going to be fun. Okay. So we have, what goes underneath here? Part 1. And part 1 is actually the what? Yeah, the filling. And we're choosing one of them. That's what that blank means, right? Choosing one filling. And or. Do we need the fillings and bread, or do we just have the fillings or bread, like you're just eating a piece of whole wheat or some egg salad in your hand? And. Okay, so we need and, so we multiply. Part 2. And what goes above? The number of choices. We're choosing one. That's what the blank means. The number of choices goes above. How many filling choices are there? 4. How many bread? So how many total sandwiches? Now, if you just put 12, and people will often do this on the diploma, and you'll be like, wait a second, and you see a written response. Like, I didn't get full marks on my written response. Well, sometimes you don't get full marks, not because your math is wrong, it's because they asked you to give them the exponent, and you just give them, like, the whole term, and when you need to circle it and say, this is the exponent, so they know what you actually found, what you need to. Make sure you write sentences. Let them know what the heck you found, right? I've literally had to take marks off on diplomas before, because I've marked them before, for not going exponent is 7. Like, you know, or even, like, they're even nice. If it's like x to the 7, they'll let you circle the 7 and put an arrow off and say exponent. Like, at least they know that you found it. Because if you just box the term, is that the exponent? No, right? So it's better to write a sentence like the exponent is 7. Then you know you're getting your whole marks. They're not taking anything away from you, and they can't. Okay? So, how many different sandwiches can be made? 12 different sandwiches can be made. Oh my gosh. This one always makes me laugh, not gonna lie. A Math 30 quiz. Just because there's the number 30 on it doesn't mean it needs to be used anywhere within this question. Like, this is just Math 30, right? Like, it's not 30 question quiz, okay? Math 30 quiz consists of 8 multiple choice questions. Each question has 4 choices, A, B, C, or D. This one is done terribly as opposed to the previous one, which is the exact same thing. This is just a test, right? So lines always represent parts, correct? How many parts does this test have? 8, right? It has 8 parts. How many parts are you completing on this test? That's what you have to think about. How many parts are you completing? You're completing 8 parts. You're completing 8 questions, correct? You would have to do all 8 questions and circle whatever and then move on, correct? So there are 8 parts. So this actually has 8 blanks, right? Because part 1 would actually be the question number 1. Then the question number 2. Then the question number 3. Question number 4. Number 5. Number 6. Number 7. Number 8. Now, we have to ask ourselves, do we have to do 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 to finish the test? Or could we just do 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 and finish the test? And, right? You should be doing them all. Yes, you could choose to not, but that should not be an option. All right. So we have and means we multiply. And add do not go together. All right. Now, we're picking one answer, correct? That's why we have a blank. Number 1, we have a blank because we're picking one answer, A, B, C, or D. You can't pick them all. Your teacher would not give you a mark, correct? And then 2, you're picking one answer. 3, you're picking one answer. 4, 5, 6, 7, 8. You're picking one answer. That's what those blanks mean, right? Above it is what? What do you put above the blank? Your number of choices. How many options you have, correct? So how many do you have for each one of them, actually? 4. Now people tell me this is 4 times 8, and that scares me. It's not 4 times 8, it's 4 to the power of 8, which is like 1, 0, isn't it? Oh, it's 6. Wait, that'll come down here. 6, 5, 6. There's one in one of these that's like 1, 0, 0, 1, blah, blah, blah. Okay, let's change this up. So actually, think about it. People who think they're not going to study on an 8-question quiz and they're going to do great, I'm just going to wing it. You have a 1 in 65,536 chance of getting 100%. Because you have to think about it. That's how many different answer keys there are for an 8-question quiz. There are 65,536 different answer keys for an 8-question quiz. Right? You could have A, B, 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 C, 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 D, 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 A, B, 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 C, 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 C. You know what I mean? Like, there are 65,000. So guessing it can be pretty. That's what I'm going to say. Now, that's an easy question now that you know it. But what they can do is they can change this question to make it a little bit more difficult and give you some restrictions. So this is how the question will go. Let's think about it. Mrs. Lepp has an 8-question answer key sitting on her table. Okay? She's an 8-question answer key. She takes her coffee, she just boom on the answer key. Okay? 3 to 8 are gone. 1 and 2 are still there. 1 and 2 did not get spilt on. Yay. Awesome. How many different answer keys could she have? So 1 and 2 did not get spilt on. 3 to 8 washed right off. Can't pick up the paper and figure it out, like cleared it right out. Paper fell apart, it's just shambles. Okay? How does that change the question from the 8 question I had before? 1 and 2 did not wash away. 3 to 8 gone. We don't know the answers to it. Yeah.
There's only 2 parts now.
Nope. There's 6 parts. There could technically still be 8 parts. There could technically still be 8 parts. Just part 1 and part 2 have how many options only? 1, whatever the answer actually is, right? If you're looking at my answer key, and sometimes it's better if you visualize actually what's in front of you, right? I said 1 and 2 stayed the same because they didn't get washed away. So say it's A and D, correct? Then these all got washed out. So these are gone. So how many options do I have for 1? 1. How many options do I have for 2? 1. So you could still draw those blanks. They would just only have 1s in them. And then how many do I have left for 3 to 8? How many options on each one? 4. A, B, C, D, right? A, B, C, D, A, B, C, D. So I could go 1, 2, 3, 4, 5, 6, 7, 8, 1, 1, 4, 4, 4, 4. Or I could, as you guys said, there's only 6 parts because the first 2 don't matter. They didn't get washed away. So it would be 4 to the 6. Either way, still the same answer. We agree? So that's how they can make it where it's a little bit different, a little bit harder. We have to visualize. And sometimes just drawing it out makes it easier. Oh, A and D? Cool. They're like, how do you know it's A and D? It doesn't matter. C and C. Like, it doesn't matter. It's still only one option. It's whatever it was. Right? Sometimes there's questions where it's like, And the last two digits are the student's birth year. And they're like, okay, cool, 10 and 10. Well, no, it's the student's birth year. It's what your year is. So what year were you guys born? 06. I started teaching here in 06. Awesome. So it would be 1 and 1, right? 1, because it'd be 0 has to be in this blank, and 6 has to be in this blank. 1, 1, right? Okay. I knew this year was going to come, that the year of your birth would be the year I just didn't realize it was so quickly. Awesome. All right. So, the fundamental accounting principle, what happens when you get restrictions? When you get restrictions, you have to deal with restrictions first, okay? So, like, for example, if I wanted to keep P at the front and B at the back, I would deal with P at the front and B at the back. If I want a blue car at the beginning of the row and a black car at the end of the row, I deal with those ones first. I have to deal with restrictions first. That's why it's written there, okay? So here it says, in how many ways can 5 different models of black cars, and this is very important. You guys, you have to always, and I didn't know this either, I was stupid. You have to always determine whether the items you're looking at are identical or different. Okay, distinctly different or identical. Because if they're identical and I have a P and a P at the beginning of my word, and I swap those P's, does the word change? Like if I have the word popple, and I put a PP and then all the rest of the letters, or a PP and the rest of the letters, it's going to be the same word, right? So if you have identical items, you have to deal with the fact that they're identical and get rid of those cases in the end. But if they're all different, you don't have identical problems. Okay? So I'm going to look here. It says 5 different models of black cars. So cool. They are the exact same black. Let's think about this. They're the exact same black. Like I found the black. I'm going to paint all of these cars in the exact same black. However, one is a Ford Mustang and one is a Ford Focus. Okay? Can you tell the difference even though they're the exact same black color? Ford Mustang, Ford Focus, right? Or Ford Mustang, Honda Civic. Like, can you tell the difference between them? Even if I painted them in the exact same black color. The cars look different, right? They look totally different. They're all black, the exact same black. Cool. But they look different. They are not identical items. And that's what we have to decide. So these are not identical. When they're not identical, life is easier. So you should like do a little shout in your head, like, hooray. Okay? Because they're different models. Okay? And then this one we have 4 different models of red cars. So yes, they're all red, but they still are not identical. So whenever you look at an item, you have to decide if they're identical. They've used flags before, like a blue flag, a red flag, and a purple flag. Okay? 5 blue, 4 red, 5 purple. Do the flags look the same though? Yeah, there's just 4 purple flags, like they're the exact same. So then I would say, oh, those are identical. And it makes a difference. Okay? We're not dealing with identical till tomorrow, but it will make a difference. All right, this is the comical of comical things, because when I did these in high school, I don't know, I thought just stacked cars. I'm not quite sure what I thought, but I did these so wrong. So you have 5 different black cars, 4 different red cars, and they need to be parked next to each other in a parking garage. Okay? Now, a black car has to be first, and a red car has to be last. So how many parks do we have here? How many are we parking? 9. So we have 9 spots, right? Because every blank represents what? Leaving what there? What does a blank represent? How many items are left there? 1, right? Every blank represents 1. That is what I did not understand. So I'd put all the cars here and all the cars here, and I'd be like, there's no more cars for the other blanks. They're all here and here. And I was like, done. I was stacking them? Like, what was I doing? I don't even know. So, and you will do that too. So watch yourself. We have a blank represents 1 item has to be left there. 1 item. The number above represents how many options, correct? But 1 item is only being left there. So I need to park 9. There's 5 black and 4 red. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. My restrictions are I need a black car in the first. And if you think that's the first, doesn't really matter. It's going to result in the same thing. And a red car in the last. Isn't it weird writing the word black and red and green? It's kind of weird. Just realize that. Okay. So I need to Nope. I need to park. I need to park a black, which was a plaque. That's how I did that. In the first. Okay. I have a blank. How many black cars am I parking there, people? 1. Little Crystal Wagner in high school thought, I don't know what I thought. I thought I was parking them all. So when I put the number on above the blank, I thought that's how many I was leaving there. Well, then they would have to be stacked on top of each other, which is very eventful, actually. But if I would have been explained to myself, I probably was. I'm sure. My teacher was awesome, so I obviously was the idiot. But that one blank means one item is parked there. The numbers above are how many options I have, not how many I'm parking. Okay? So how many black cars do I have? 5. How many did I park? How many black cars do I still have left? Not all of them are gone, correct? I thought they were. And I was like, what the heck am I parking there? It's true. Sad, but it's true. Red, okay? How many red cars do I have? 4. Perfect. I parked it. I have to do my restrictions first. How many cars did I park there? How many options did I have? Cool. Now I have parked how many cars currently? 1 and 1. Yeah, you were marked for the red. Yeah, 1 and 1. So I've parked 2. Out of how many?
9.
How many do I have left?
7.
So how many options do I have for this blank? Now you could do any random blank. Doing any random blank actually bothers me immensely, and I don't know why. You could literally do any one. I like sequentially doing things, so I'm going to go downwards, but you could literally put a 7 here, right? It doesn't matter, because I have to do the restrictions and then any order. But I'm going to start here. So now I have 7 cars. I pressed red. I swear I did. 7 cars. Then how many here?
6.
Then?
5.
Then?
3.
Then?
2.
And I'm going down by 1 because I'm parking a car in each of those spots, right? That's what that blank means. I'm parking a car. The top is how many options, not how many cars I park. Okay? All right. So what we're going to do here, this is the last thing we're going to do today. Well, last thing, we're going to discuss something else after this. But the green ones, 5 and 4 add to what? 5 times 4, not add. 5 times 4 give you what? Result in 20. Okay, you could literally do this in your calculator. You could go 5 times 7 times 6 times 5 times 4 times 3 times 2 times 1 times 4 and get an answer. You absolutely could. I'm sure a few of you have. Totally fine. What I'm going to do, though, is I'm going to split it up because I'm lazy. So 5 times 4 is 20. So I'm going to go 20 times. Now, this is the coolest thing. If you can count down numbers to 1 and say blast off like you were taught, because in kindergarten, one of your outcomes is to count down from 10 to 1 and say blast off. I know it's because my friend's a kindergarten teacher. It's the only reason why. So if we can go 7 times 6 times 5 times 4 times 3 times 2 times 1 blast off, the blast off is actually a factorial symbol. So we can do this. We can go 7 factorial. This is like the little blast off symbol. It's like a little rocket. So anytime you have a number to 1 and every number in between, you can use that. Could you actually use it if you don't have the number 1? Yes, because multiplying by 1 doesn't change anything. It's not a true factorial, but you could use the button and it would get you the same answer, right? Because 7 times 6 times 5 times 4 times 3 times 2 is the same as 7 times 6 times 5 times 4 times 3 times 2 times 1, right? So if it didn't have the 1, you could get away with using the factorial symbol. Now where is that little ditty? Okay, grab out your calculator.
What's a magic?
I'm too lazy to bring up my TI-83 right now. It's going to take me equally as long to get it to show up at the end of class. It takes forever. So go 20 times 7, and then I want you to do this. This is where we're going to live for this unit. You're going to go 20 times 7, and then you're going to go math. And you can arrow to the left twice if you use the fancy shiny ones, or once. Either way, you're getting to the PRB. Or you could be an overachiever and hit right 3 times. It doesn't really matter. You just need to get to the PRB, because that's the probability button. That's where we're going to live for this unit. And you're picking number what? 4. 4 is that factorial symbol. So we went to math. We arrow to probability. You can arrow left to get there faster, or you can arrow to the right to get there slower. It doesn't really matter. Get to PRB. Pick number 4. Hit enter. Okay? Now for fun, go 5 times 7 times 6 times 5 times 4 times 3 times 2 times 1 times 4. Just to prove that it's just, that can bring you joy too. It doesn't really matter. So what is the answer to this one? What do we get for this one? Here's my little 100. One of them started off. So would we just do that, or are we going to write a sentence? We're going to write a sentence. It says, in how many ways can you park 5 different models of black cars and 4 different models of red cars? So I would say there are 100,800 different ways you can park 5 different models of black cars and 5 different models of red cars. On the diploma is not where I'm saving pencil. Okay? I am using as much pencil as possible. I will write out everything.